So you see the second part of the uh, problem 1, rigid body kinematics 1, which we are on the step that want to find out the point beat properties from the body properties. And the step, previous video, we move from the point properties A to body property of the Ferris wheel, and we find out the body properties. In this case is omega, 2 radian per second, and as I explained in the first video, it counterclockwise because the problem is in motion counterclockwise, and alpha is consistent with the 80, so it will be clockwise. So keep that uh, direction, and then now continue with the point B properties. And as you can see here, you see point B, and the horizontal is 12 and the vertical is 5. So you have 12 feet, 5 feet, and then this one have to be 13 feet, as you can see there. So let's draw, before we start to find out the point property, we need to draw the raphastic OB. So raphastic OB that rotate about point O, so we can there, and point B there. And from body properties to point properties, so you need to draw the body property first. Omega, 2 radians per second here, and counterclockwise, so counterclockwise omega 2 radian per second. And then the other components, alpha, another body properties, alpha 3 radian per second clockwise, so we can have alpha, and in this case 3 radian per, let's write bigger here, alpha 3 radian per second squared. And in terms of the geometry, we have radius OB, radius OB, or B relative to O, equal to 13 feet, as I saw earlier there. And slope triangle for this one, if you want to know, then it will be 5 vertical, 12 horizontal, and of course the diagonal will be 13. So find out the velocity of point B, normal and tangential components, accelerations of point B. So draw it down, alpha, and you can see clockwise, then the tangential components have to be consistent with alpha, so it have to be go in that direction, A, B, T, point properties. And ABN is always parallel to the radius and direct to the center O, so you have it A, B, N. And the other problem the question asks is, what if velocity of point B? Velocity of point B and omega have to be consistent or same direction. So as you can see, omega go counterclockwise, then that one we have V, B have to be go in that direction and perpendicular to the radius. One of the characteristics of velocity, and in the lecture that you have. So from that you have body. Now find the point property. So just recall the relationship in terms of the equation we have. So if talk about the velocity, you have VB that equal to omega R B relative to O, and you see that omega is body. Now we find our point property. Omega equal to 2 radian per second, and then OB 13 feet times 13 feet. So here we have 26 in this case feet per second square, and the direction is, let me rewrite that to make it clear for the direction. So we have VB equal to omega times R B relative to O, so it equal to 2 times 26, no, 2 times 13, try it again, 13, so it will be 26 feet per second, and in this case you can see going down, so we can make the direction go down. What should be the slope triangle here? You just flip perpendicular, so it will be vertical, it will be 12, and because perpendicular to OB is vertical 5, then you flip become 12. Horizontal of the OB equal to 12, now you flip to 5. That the velocity of point B, and that is the first answer you need to find out. The next question is, what is the tangential and normal components of acceleration B? Again, we just go ahead to apply the equation. Let's start with A, B, T tangential equal to alpha R B relative to O. Alpha is 3 times 13, the radius, so you have it 39, and in this case feet per second square, and the direction go up. The angle it should be collinear with the velocity, so just flip from the radius OB, so it will be here is 5 and here be 12, and then the last will be the normal components, and we do exactly the same there. So the normal component A, B, and if you recall, that is omega square R B relative to O, so omega square, it will be 2 square times 13 feet, so you have 2 square is 4 times 13, so it will be 57 feet per second square, and the same at the slope, it will be same at radius because it's parallel to the radius, so 12 and 5, and this is the last final answer we want to find out. So that you can see, the bottom line for this problem is you need to ask yourself this question, and similar ask for the next question, next problem. What is given? Body or point property. How many rigid body? If have 2 or more bodies, then where are the common points? We don't have it here yet, this problem yet, but it coming for the next problem when they have 2 bodies. And when they give you point property, the next step it have to be body properties. When they give you body properties, next step it will be point properties, and keep that process. And you can see step 1, we want to have from point to body, and then body to point. Never jump point to another point properties. Never jump body properties of this richest body to body properties of the other richest body. Need to go from the common point. With that, we finish the solution for the first problem of the richest body kinematic.